Trigonometry and geometric reasoning test refresh. Why am I doing this? You got an extra week to revise for your test. Why? Because you were disrupted by work experience, and also I justified it because we smashed you with the quite hard maths right at the beginning. Normally, year 10s only get that hard maths. It hasn't even started yet. It only happens towards the end of term 2. So your upcoming test can be boiled down to 5 separate things. There could be 5 sections on your cheat sheet. The first thing that we covered this topic was how do I find unknown sides with SOHCAHTOA. When I was going through this, you guys seemed very confident with it. So whoever you've had previously did their job effectively. I just did it my way. So I asked you, can you check? Do I have a right angled triangle? That's check 1. Check 2, do I have one known angle? And check 3, do I have one known side? If you have those things, then you can use the ratio. There's 3 of them there, SOHCAHTOA. That involves the known and unknown sides. So if I had this question here, find x, I'm finding an unknown side. So do your 3 checks. Is this a right angle triangle? Yes? Do I have one known angle? Yes? Do I have one known side? The hypotenuse. So now, if so, then use the ratio SOHCAHTOA that involves the known and unknown sides. So I have the angle here. What is this side in relation to the angle? Is it opposite? Is what's this? Hypotenuse. So which of the ratios involves opposite and hypotenuse? So, because it's O and H. So sine 30 degrees is equal to opposite x over 12. I'm almost there. I want x by itself. I need to get rid of dividing by 12, so you times by 12, but to keep it balanced, I have to times both sides by 12, so x is going to be 12 times sine 30 degrees. And if you have a calculator, I'll have to get mine out now. Sine 30, then times it by 12, I get 6. So what do you get? Check for me. 6 centimeters. Does that show you how to find an unknown side with SOHCAHTOA? That's the first thing. Half of the first page is done. Second thing, finding unknown angles with SOHCAHTOA. You were less confident with this when I first taught you, but I know that I got the impression you still covered it. So whatever teacher you had, they did their job. So what do I check? Do I have a right angle triangle? Do I have 2 known sides? If so, then use the ratio SOHCAHTOA involving the 2 known sides in relation to the angle that you want. There is an extra star here. During calculations, when you want to divide by sine, cos, or tan, you can't on a calculator. Your calculator doesn't let you divide by these things. What you do instead is use sine to the -1, cos to the -1, or tan to the -1, which is the same as dividing by those. So here, check, is this a right angle triangle? Oh, I didn't put theta. Let's put theta there. Is this a right angle triangle?
Yeah.
Tick. Do I have 2 known sides?
Yeah.
So, which ratio involves when we need to label these in, good, because this is opposite and this is adjacent. So tan of an unknown angle is equal to opposite 3 over 4. Right now, I want to divide by tan, but I've just told you you can't. So what you do on your calculator is you go theta is equal to tan to the -1, whatever 3/4 is. So if I go 3/4, it gives me 0.75, and then I go tan to the -1 of 0.75, I get 36.87 degrees rounded to 2 decimal points. Okay? I'll give you some time if you're getting that down to get the first 2 things that we do. Yes?
What do you press to get the -1?
It depends on your calculator. So if you're using one of these small ones, See how it's the -1 is in yellow, so you press second and then press the button.
Okay.
A few minutes, 10 past, okay? Yeah. Is there anything there that, because you're looking at it, right? Which step? With? Yeah. Was this one alright? You're using the same ratios.
I think it's why do you divide?
Because in algebra, let's say we wrote a b is equal to, I don't know, 2. What is the sign in algebra that we don't know? Sorry? Well, the number, yeah, but there's a sign that we don't write, like what is given good? Yeah, a times by b. So at this point, you've technically got this ratio here, it's like it's tan times by theta is equal to 3/4. And I want this by itself. So what do I want to do? I want to divide by this. Your calculator doesn't let you divide by it. So instead of dividing by it, we multiply by the reciprocal of tan, which is tan to the -1. It's the same thing. Okay? So that's what that step is. Yes? 3/4. Yes. Because multiplying by the reciprocal is the same as divide. Okay? If I do 2 divided by a half, okay, I'll prove that to you. How many halves are there in 2 wholes? Take your time. Good. You know what the answer should be. So if someone's teaching you how to multiply and divide fractions, they would tell you that dividing is the same as timesing by the reciprocal. So what is the reciprocal? What is 1/2 flipped? It's 2/1. So it's going to be 2 times by 2/1. What is 2 times by 2? 4, which is the answer that you know. Anything raised to the power of -1 is the reciprocal. So that's why that works. The next thing that we did was congruent triangles. You seem very confident with these. Nope. That's what we're going over right now. Congruent triangles. Triangles are congruent if they meet the following conditions. Can someone remind me what SSS stood for? Yes?
Side.
But what? Are they all the same or are they all in proportion?
Same length.
Good. All sides same length. Well done. What is side angle side? Not Special Air Force or whatever it is. Side angle side.
Yes, I think so.
2 sides same. What was special about the angle? There's a reason. Good. 2 sides same. Angle. Included angle same. AA core S. It might have been taught to you as AAS, but I think the core is important. What is that? Good. 2 angles same and a corresponding side. Corresponding. And what did RHS mean? Right angled. So you check that it's a right angled triangle. The hypotenuse is the same and one other side corresponding on the side same. And then I showed you, you seem to have an idea about it, but you can only prove congruence with a 2-column proof, which takes this form. You make a statement. Can someone remind me what the 3 dots pointing, that's because. What was it when it was pointing up? Good. So you make a statement, and then you go because of a particular reason. The symbol for congruence is this, an equal sign with a tilde symbol above it. and then I provided you a PDF. It's attached to DayMap now. Many of your reasons, many of these, come from the geometry facts attached to DayMap. If you don't remember those, chuck them on your cheat sheet. You seem to be aware of them because when I did this, and I said, well, what do we know about angle A and B if those are straight lines? You told me, it was him, you told me that they were equal. And then you told me because they're vertically opposite. So you had a good idea of that. If you need a refresher, the geometry facts are on a PDF attached to DayMap, okay? If you're not confident with remembering them, chuck them on your cheat sheet. Let's practice a proof. So we're going to prove something using congruence. Prove that AB is parallel to DE. Anyone have any suggestions how we could go about that? I've got two triangles. Yes? Ultimately you're right, but we need to prove that these are congruent to do that. And I haven't
On the
proven
side
any
angle
of the...
side.
Yes, but what? Let's do the argument.
Because angle DCA and ACB.
Good, so this is what I mean by the two
on the
congruent. So,
opposite
what is your statement? Angle DCE, this one,
Yeah, and ACB.
is equal to angle,
ACB.
and what reason did you
It's
use?
the vertically opposite.
Vertically opposite. We're being little mathematical lawyers here. We've proven one. Do I have... He knows that he wants to get side angle side, but I've only proven S right now. I've only proven A right now. So, give me more. Good. DE. Sorry, no. I don't know anything about DE.
Oh. DB.
DB. DB's on a... Good. There we go. DC is equal to what? Because there's no reason for that. Is it literally told to you?
Yeah.
So you can write given. So we've done side angle, but I don't have three things yet. So let's try someone else. What's another side?
AC.
Yeah. AC is equal to EC because given. What do I say now? Therefore, triangle DCE is congruent to triangle ABC. Why? What reason did you use? You told me the side angle side. Because they're congruent. Because, so now you can say something like because congruent. Angle, what can we say about angle CAB and angle CED? Because they're congruent. You've proven that these triangles are exactly the same.
Oh, that.
What can I say
that
about
was the
this
same.
and this?
That is okay.
Good. Congruent. Because congruent, angle CAB is equal to CED. And because of that, if you look at your geometry facts, you would have a little thing that looks like this. If you've got two parallel lines and a line going through it,
Same angle.
this angle is the same as that. Is that what we have here?
Yeah.
If I did a dotted line through here, and this is a straight line that goes through those two lines, we just proved that this angle is equal to that. So what could we say about AB and DE using this?
They're parallel.
They're parallel, and what reason do we have for that? Do you remember what it was called? Alternate?
Yeah, alternate angles.
Yes. Therefore, DE, the sign for parallel is two vertical lines, is parallel to AB because alternate angles. Okay, I'll give you 5 minutes. Can you get that example down if you're not confident with it? Question, you're pointing. Question? Ask me. Yeah?
Why is it CAB?
I could have...
At the triangle.
Oh, but you wanted it to be EAB.
No, I mean, why do you have to write 3 letters for the one angle?
I could, if I labeled it as the small a, I could have just called it small a, but if I don't have that there, I need enough information to tell me where the pivot point of the where the location of the angle is. I can't just say the angle is A. A is that corner of that shape. The angle is formed between C, A, B. Does that make sense? So the center, where it bends, is the middle. It's just so that we've got clarity. I could, I thought you meant that I could have called it EAB. You're right. It's still correct though, isn't it? If I called it angle EAB, that is perfectly right. Because I'm still pointing at this. What would that angle be called if I extended it? AED? I could also call it DEA. It's what's important is the middle one. Does that make sense? Okay, give you some time. Can you get that example down? Yep. Yep. Because you came in after, just get down what you're here for, but I'll upload the video. This is like a test refresh. Okay, because we postponed it a week. It's just doing everything that we did over the course of like a couple of weeks all in one go. Because people are focused on work experience. Do you know how to spin wheel? You know how to spin wheel? Means differentiate with practice. No, but giving it forward. Okay, throw it. You're supposed to my hands. But as you release it, it rolls off like that. It's really hard to do. I've got small hands. Don't show me. If I get conked in the head on video, I would leave that in because that would be extremely entertaining. A couple of minutes and then I'll finish off with similar figures and similar triangles. Actually, no, I can move this because I'm not going to erase it. It's all on this board. No, it's still there. Let me finish off with similar figures and similar triangles. Two figures are similar if they have the same shape, so the same angled corners and everything, but they are different size. That means all sides are in proportion. What does this mean? This means all sides of one shape were multiplied by the same scale factor to get the other shape. So for example, I have two rectangles here, A and B. What scale factor was applied to go from A to B? Good. See how you worked that out? How did you work that out in your head? Good. So the other way you could do is go, well, what happened to this? Did it get enlarged or did it get reduced? It got enlarged. 12 divided by 3 is equal to 4. So what was the scale factor? Scale factor equals 4 because I multiplied all the sides by 4. Okay? Last one, similar triangles, then I'll finally shut my mouth. Please remember we're doing this all in one go, whereas we did it over 2 weeks when we first taught it.
So, what's the title for that one?
Just similar figures.
Oh, okay.
Similar triangles. Triangles are similar if they meet the following conditions. What do you reckon AAA stands for?
Three angles.
Well, all angles same, and it's 3 because we're talking about a triangle. SAS, be careful, we're talking about similar now. Yep.
All sides are in proportion.
That's going to be this one because it's SSS.
Oh, I'm sorry.
This one.
Yeah.
That's
Sides
fine, don't be
are
sorry.
proportion and the angles the same.
Because we'll use yours next.
Yeah.
Yeah? Two sides in proportion, one angle same. Then yours, all sides in proportion. And then this one, right angled. Hypotenuse and one side in proportion. These are very similar notes to the congruence one. You prove similarity with a 2-column proof. The symbol for similarity is an equal sign but wiggly, 2 tildes. Many of the reasons come from the geometry facts attached to day map. Similarity is useful because knowing things are similar means their sides are in proportion, meaning we can use the proportions to find unknowns. Congruence isn't that similar because I need the triangles to be exactly the same. If I knew two triangles are similar, it allows me to find unknowns that are a bit more useful. Find x. We need an argument here. How many triangles do we see? 2. What is special about these two lines?
Parallel.
They're parallel. Do we have any letters right now on the corners? It's going to be hard to pose an argument if I don't have labels. You're allowed to label them yourself. So just go alphabet in a clockwise direction. Now we can pose an argument. How can I prove that the smaller and the larger triangle are similar to each other? They're not congruent, obviously, because give me something. I need 3 things because I need to prove one of these. Okay, is there any way that I could say that 2 angles are the same in both triangles? Is one of them literally drawn the same? Yes. But say it right. EAB.
Yes, that one.
So, first argument. What an opening argument of a lawyer. Angle EAB is equal to angle. What is that angle in the larger triangle? DAC. Because it's literally drawn like that. But you guys gave me a better way to say it. You guys said shared. I'd never seen that before, but I'm going to use it now. I would have said given before I met you, but I like shared because it's shared. It's the same thing. That's 1. Angle. We don't know anything about the sides because this is unknown, and the multiplication you get from 15 to 24, we don't know. Okay? Could we do angles though? It's probably got to do with the parallel lines. Yes?
Would they be the same?
Yes, yes. Why though? We have 2 parallel lines and we have not alternate because it's not going either side. You have a straight line going through there, straight line going through there. There's a little drawing in your geometry facts that shows this angle is the same as that. The reason started with a C. Corresponding. So corresponding angles. We're going to use the same reason for both of those. So angle ABE is equal to angle ACD because corresponding. We've only done 2 right now. We need 3. So the remaining angles, angle AEB is equal to angle ADC because of the same reason, corresponding. Based on this argument of 3 things, which similarity proof do we have? Have we done any sides? Have we done any sides, or has it all been angles?
All angles.
All angles. So therefore, triangle AEB is similar to triangle ADC because of angle, angle, angle. We haven't answered it yet. We need to find x. Why is that useful? Why is proving similarity useful? Yes?
Because we know they're proportionate.
We know that these sides are in proportion. So this side matches this side in the triangle. So because sides in proportion, what could we say about side EB over DC? That should be equal to, comparing that side to that side should be the same as comparing the AE to the whole thing. So AE is the same side as AD. Right now, these are all unknown. But we have numbers for that. How long is EB?
15 centimeters.
How long is DC?
24 centimeters.
How long is AE?
X.
Is the thing that we want to find. Careful, take your time. I want someone else to answer this. How long is A down to D? 12 times by X? 12 plus X. Well done. 12 plus X. Do I have a fraction and another fraction? What's the
Cross
way?
multiply.
Let's multiply. You have to be careful. This is a complicated thing, so I need to chuck it in brackets. So it's going to be 15 lots of 12 plus x. To do that multiplication equals 24x. 15 times 12, I don't know that off the top of my head.
180.
180. 180 plus 15x equals 24x. Do I have x's on both sides? I want x's only on one side. So what's the opposite of adding 15? Good. Take 15 from both sides. What's 24 take 15? 9. What's the 9 doing to x? What's the opposite of timesing by 9? Divide both sides by 9. I think that's 20.
Yeah.
X is 20. Your test is made up of that. Okay? Those 5 things. I suggest that you use this double lesson and Friday to make sure your cheat sheet's up to scratch. Any of the geometry facts attached to DAMAT that you don't remember off the top of your head, you did remember it, but you took coaxing. I'm like, the letter starts with C. Oh, corresponding. You need to have it on the top of your head. Okay? Get on to it, please.